So my, how about I move some things then out of the way here? My instruction was raise your hand whenever you feel like it. And, in time, you could have decided to move whenever you wanted to. And of course, let's say you decided to move at this time, and then you could decide which hand you want to raise, right? And let's say you decided to raise your right hand. Okay. So the thing that I wanted you to experience is really that everyone here experienced that it's up to them. When you decided, it's not like some kind of random thing. It was up to you. You decided when to move, and you decided which hand to move. It's also the case that you feel that you control the movement. So if you come to the Brain Institute, we could trigger a movement using transcranial magnetic stimulation. It's called TMS, and we can make one of your hands move. This was not the case. You moved yourself, and you felt that this was your own action. And more than that, what I suspect happened is that, I requested that you move whenever you wanted to, which then, which then led to you thinking about it, deciding at some point to move, and then moving. So this leads us to the problem of free will, in the sense that, generally speaking, adult humans typically experience being in control of their own actions. They feel that their behavior is really up to them. And there are a lot of questions about how that experience tallies with what we know about the laws of physics, perhaps especially with determinism at the level of the brain and so on. There's this question of, really, is the future really open? Can you really make different decisions? Or maybe it was predetermined and so on. I'm not going to talk about that so much, but in terms of what we experience, I would argue that we experience our mind to be something like this. So there are various external influences. I asked you to raise your hand, right? That was an external influence. There might be an internal influence. Maybe you said to yourself, I want to be first, like Ralph, and he raised his hand really quickly. Or maybe you said, I'll wait for everybody else and see what they're doing and do it. So there could be various internal influences as well. But I think that we feel that we are divorced from all of that, and that somehow our consciousness kind of influences our behavior without all of those influences, or at least we can neglect those influences to some degree. Now, the problem of free will is an ancient one, right? And roughly every major philosopher, at least Western philosopher, has had something to say about it, from from Plato to Thomas Aquinas. We have René Descartes, Immanuel Kant, Friedrich Nietzsche, Harry Frankfurt. And then in 1983, neuroscience joined the debate. So my field is interesting because we know when it started. It started in 1983 by one paper, a very seminal paper, and a germinal paper as well, by Benjamin Libet. So I'll say something about that, but before that, I want us to think about the intuitive order of events. So what happened when I asked you to, at some point, decide and raise your hand? The order of events that I think people generally experience is that they make a decision to raise their hand, and then, again, we experience that decision to cause our hand to rise. So if we think about the order of events, there's the onset of the intention. After that, after the onset of the intention to raise your hand, you would expect the information to exist in the brain. I can find it, the person's going to raise their hand. And then after that, the hand rises. So this is the intuitive order of events. So then what happened in the Libet experiment? Libet experiment is actually not very different from what you did here. Libet had participants. I mean, there are various versions of this, but in one version, there were actually two hands. So whenever you feel like it, raise one of your hands. And the difference was that the participants had in front of them this clock. So you see this clock here with a dot. This dot started rotating, and it would make a full rotation every 2.56 seconds if you really want the details. But the point is, it served as a clock. So when you raise your hand, what Libet asked was, where was that spot on the clock when you first had the urge to move? So he had a way to try and time when people had the urge to move. And it was also known at that time, so this experiment was done in 1983, but it was also known since 1965 that there's something called the readiness potential, or the, oh, not move. That's against everything I've been taught about how to teach at Chapman, but okay, I'll do my best. I will stand right here. So here is okay? Yes. Okay. It's an interesting question of what's happening right now, but anyway. So this thing called the readiness potential, or I mean, the talk before me had a lot of German, so I'll add my own Bereitschaftspotential. It was found in Germany in 1965 by Kohn, Huber, and Dicke. So, but it just really means readiness potential. Supposedly the brain gets ready to move. So it kind of looks, it looks like this. Let's have a bigger picture. So it depends which EEG system you use, but something, let's say like a second before you move, you start seeing this component kind of decrease and then start increasing again before movement onset. So we would say that the readiness potential maybe starts here, maybe a bit later, but somewhere around here is where the readiness potential starts. So supposedly that's where there's some information in your brain that you're about to move. And then, of course, the interesting thing is, where did people report using that rotating dot, that Libet clock? Where did they report the onset of their urge to move? Well, it happened here. So there's already something interesting happening here, right? If we talk about the intuitive order of events versus the Libet order of events. So the intuitive order of events was that there was the onset of the conscious intention. After that, there's information in the brain. After that, there's movement. But the Libet experiment says, no, the information in the brain exists before the onset of the conscious intention. So of course, then there's the, wait a minute, so what happens here in between? This is supposedly a time where I, as a neuroscientist, can, just so I can see people, I guess, can, I don't know, it's not gonna work. I, as a neuroscientist, can already tell from the brain activity that the person's about to move, yet they apparently are unaware that they're about to move, right? So the information exists in the brain, the person is unaware. So then a quick question that came about was, well, maybe these conscious intentions, my conscious intention to raise my hand is not even part of the causal chain that makes my hand rise. So this idea that my intention causes my action to rise, maybe it's just not true, okay? And of course, the Libet experiment, this interpretation, so if decisions are really made, are really made unconsciously, this has wide-ranging implications. Has implications for the debate on free will. It has implications for moral responsibility, because many views on moral responsibility assume some kind of free will. It has implications on moral theories that assume that we are free to make decisions, therefore, and so on. It has implications for various social pillars of human society. So it would not surprise you that this Libet experiment has been seminal, germinal, and very influential. I looked this morning and it was cited exactly 4,000 times. I wish upon you all that all of your papers will be cited this much. But the influence has gone beyond just the academic circles. It was also mentioned quite widely in the lay press. And just as an example, again, I looked this morning, just in the New York Times, the Libet experiment was mentioned in 35 different articles. This is just the New York Times. So Okay, it's been very influential, and of course, it did not.
What was the date of the experiment?
1983, it was done. It was actually done in 1982. It was published in 1983. And by the way, if you want to know all about it, Marco or anyone else, we just published something we call the Libet Primer. It was about 120 pages, all about the Libet experiment. So Marco, you can know all about it, and anybody else here is interested. It's Dominique et al. And I think it's actually coming out next week. But anyway, so there are various criticisms of the Libet experiment, to be clear. It's not, does this Libet clock really measure the onset of the conscious intention to move accurately? We'll talk a little bit more about that. There's also, I mean, the time difference, right? Between, on the one hand, the onset of this readiness potential, sometimes called the RP, readiness potential, and the onset of what sometimes is called W time, this time when people report their conscious intention to move, is some fraction of a second. Actually, in Libet's time, the EEG machines were not as good, so it was only about 300 milliseconds between the onset of the readiness potential and this W time. But just to mention that some studies since then, there was a study done with fMRI, that's another brain imaging technique, that actually found some kind of correlates of the decision to be made up to 10 seconds before the decision. So the idea that, well, it's just a fraction of a second kind of no longer holds. Yes?
Suppose you wired me up, we're going to do this. But the condition, I'm going to raise my hand in exactly an hour. I have a clock.
Mm-hmm.
So you're measuring the potential up to that point where
there will not be a readiness potential. If you know when you move, there will not be a readiness potential.
Right.
It's actually, by the way, it's used in neurology so when people have tics, for instance, they don't see readiness potential, but if they try to affect the same movement, they would see it. So it has to do with, yeah, it's a clinical thing as well. Yeah. Okay. So interjection of a personal story here. So when this paper came out in 2008, I was actually heading this group of mainly philosophers and neuroscientists that were discussing the influence of neuroscience on society. And this paper just came out, and of course it made the headlines. It was Science's one of the 10 papers of the year, and Scientific American had something about it, and so on. So, you know, and it was my field, so I was really excited about it. And I sat there reading it, and actually this person named Ram Rivlin was passing by, and he was in this group, and he saw me really excited. And he said, "So what's going on?" I said, "Oh, this study came out, and you can look into the brain, and you can see that somebody's about to move 10 seconds before they move, and it's really exciting." And he said, "Wait, I don't understand why it's so exciting." And then I said, "Oh, okay, wait, sorry, I didn't explain well." And I went like for 20 minutes, and I went into the fMRI, what it means, and he says, "I still don't think it's exciting." And within about 10 minutes, he convinced me that there are so many problems with that study that are conceptual problems, that there is a long way between that study and getting excited. And then I realized if you can't beat them, join them, and I must work with these philosophers. Otherwise, they will just damn all my research to hell. So later on, I worked with Gideon Yaffe. At the time, he was at USC. He's now at Yale. And I'll talk about some of our research later. But this, for me, honestly, personally, was a seminal moment because I realized that there were a lot of conceptual issues. Now, to be clear, conceptual issues about the Libet experiment were known well before my conversation with Ram Rivlin in 2008. There was actually a 1985 paper that laid out quite a few of them. But and I mean, I'll mention a few. One has to do with the specific Libet experiment. Libet made a mess of things because he was talking about he was talking about urges to some participants, decisions to other participants, volitions. It was a mess. Like the instructions were a mess. And you know, I can have many urges right now, right? I might have actually the urge to stop talking. it gets a bit embarrassing, but but I have many urges, but I don't act on all of those urges. I can have many urges, but typically I cannot have many intentions, right? I might have an urge to go to the party next week and an urge to sit and work on my paper. But it's not logical to say that I have the intention to do both. I can't. That's illogical. So urges and intentions are different. And you have to be careful what you tell your participants in an experiment. There are also other questions that have been raised. One of them is, does the onset of this readiness potential, does that really designate the onset of the decision? And that's actually one of the criticisms that I heard from Ron Rivlin that day. He said, how do you know that the decision was made 10 seconds in advance? Maybe they see some kind of fluctuating preference, right? And I mean, when he said it, of course he's right, but I have to say, I didn't think about it before that. Maybe I'm a bad scientist, but I would argue that it's not just because of that. And actually, by the way, later on, we looked into it and we saw that it might really just be a fluctuating bias. Another thing that was raised in that conversation that turned into a relatively big paper was, well, so let's say that you're sitting there and you have to raise one of your hands, and that I can predict from your brain that you're going to raise your right hand. And maybe even before you know it. Remember, you're doing that for half an hour. You sit there and they go like this, and after a while, okay, this. So at some point you zone out and I can predict what you'll do before you become conscious of it. So what? Does that mean that for important decisions, when you decided whether to accept the invitation to this conference or not, was that the same kind of decision? When you decided on your last job offer, who to live your life with and so on? I mean, do the Libet results generalize from these arbitrary decisions to deliberate ones? Again, we'll say something more about that. But what I want to say here is that for the dramatic interpretation, the one that kind of is earth-shattering, there's no free will, there's no moral responsibility and all that, for that kind of interpretation, you need at least the following three things. You actually need more, but at least the following three. You need that the onset of the readiness potential, RP onset, needs to be at least roughly the onset of the unconscious intention to move, right? And on the other hand, you need that the onset of this W time, that W time would be roughly the onset of your conscious intention to move. And then you have this interesting gap between them. And still, you need these Libet results to generalize from the very trivial setting of raising one of your hands for no reason and no purpose to real life. Alex?
Just good. I'm not sure I understand what unconscious intention is. Exactly.
So this gets into interesting philosophical debates about whether those, whether those exist. Whether those exist. Okay, let's save that. So some philosophers claim that there aren't. There's this between was it Brightman and Melia? I'm not a philosopher, to be clear. But let's bear with me and let's wait with this until the end, because I want to get somewhere else with this, and this could be the next half an hour easily, or the next 500 years. So yeah, okay. So I wanted to state that there are at least these three things that need to be met for these dramatic results from the Libet experiment to have a real influence on our lives. And I will argue here that actually all three are not met. So one is the onset of the readiness potential, really the onset of the unconscious intention to move. And for our purposes here, let's call the unconscious intention to move, Alex, just the fact that from the brain, I can see that you're about to move, and perhaps you're not aware of it yet. I'm giving it a bit of a weird definition, but let's stick with that for a moment. So actually work by Aaron Scherger here at Chapman now, and my colleague at the Brain Institute, quite an important paper in our field from 2012, suggests that it might not be. So the readiness potential, if you talk about what happens at the beginning of the readiness potential, it suggests that something really has to happen in the beginning of the readiness potential. But what he did was, using this drift diffusion model, he basically ran a lot of drift diffusion, runs of the drift diffusion model until they reached a threshold. And then he noted where you see here with these arrows where the threshold was crossed. And then he said, okay, let's look at that threshold crossing and let's look backward in time, because that's actually how you compute the readiness potential. You look at movement onset and you look like backward in time, see what happened before movement onset. And he basically showed that if you take any autocorrelated signal and you stop when it crosses a threshold, and you play with the math, and you get this thing here in black that looks very much like the readiness potential here. So in this interpretation of the readiness potential, what happens in the beginning of the readiness potential? Nothing. It's just the start of the trial. Nothing happens. So if Aaron is right, and if his model, and at the outset it was like an outsider model, I think now it's more accepted in the field, then the fact that the beginning of the readiness potential happens before people report having decided to move is not that surprising, because nothing happens in the beginning of the readiness potential. Okay, let's go to the other side of this, to this W time that I mentioned. So the time when people report on the Libet clock, oh, I've decided to move. There's actually quite a bit that claims that that's really not the onset. I'm sorry, this is actually a mistake. This should have said the onset of the conscious intention. I'm sorry, this is a mistake here. It should be conscious intention to move. But so that's not really the onset of the conscious intention to move. We just published a review about that, but more generally, there's, for instance, there was a nice experiment that was done where people could not see their own hand, and they had to press a button whenever they felt like it. But it was these buttons, like these capacitor elevator buttons, when you don't really feel when you press it, a bit like, you press the iPad, you don't know exactly when, because you could feel it even before you already touched it. And what they did here is they gave them a tone feedback, supposedly when they pressed, and they moved that tone feedback forward in time. And lo and behold, people's W time moved with it, suggesting maybe all of this W time is backward inferred from when you think you moved. And again, there are other things. If you do a certain type of TMS with this thing where you can kind of, for our purposes here, you can say that you can confuse people with it a little bit. People actually tell you that they moved much later than they did. So there are various reasons to think that this W time is just not a very good measure of when you moved. And I mean, that's what we kind of concluded at the end of our review, saying that W measurement must unfortunately be discarded as a measure of the onset of the experience of intending to move. Last, cannot be generalized to real life decisions. This is work with colleague Liad Mudrik from Tel Aviv University, that same Gideon Yeffi I mentioned before, and with Christoph Koch, who was then at Caltech, now at well, actually he's just now left the Allen, so he's now with Tiny Blue Dot. What we actually showed there was that this readiness potential that you see so nicely in these arbitrary decisions, if you have people do deliberate decisions, and we had them make real donations, I mean, we gave them the money, but a donation of $1,000 to a nonprofit, the readiness potential just goes away. It's not there. So whatever you think happens during the Libet experiment, for a real life situation, when you care about the outcome, it's not there. I should actually mention Ralph is here. He was very instrumental in that study back when at Caltech. Okay, so all of this to say that there is scant evidence for the claim of the Libet studies that basically consciousness plays no role in the formation of human decisions and actions. But the Libet studies have left us with a lot of other interesting questions, like what are the neural mechanisms that underlie self-initiated actions? What is the role of consciousness in decision-making? What are the neural substrates of intentions in humans, and many other things. Now, I mean, I'm telling you all of this in this context, not just about our work, but actually we're here to kind of ask about how neuroscience and philosophy can potentially help each other. So with that as background, I'll say the following. I think that, I mean, this is a fictitious country that I try to draw. I try to get ChatGPT to draw it, but unsuccessfully. So I ended up with something like this, which was, until a few hundred years ago, completely dominated by philosophy, right? All the sciences were philosophy. But in recent years, it seems that neuroscience is kind of encroaching and saying, no, that's ours, that's ours. There's even I've seen a term for it that's called neuroimperialism. So apparently now you've got neuro law and neuroeconomics and neuroaesthetics. So neuroscience is apparently trying to take over the world. Only I wish, but anyway, neuroimperialism. I heard it at a conference. I looked for it today because I wanted to see who coined it. You could say I coined it here, but it's not true. I don't know who coined it, but it's I like that term because it has the interesting ring to it. Although you could argue whether it's true, but that's another thing. But I want to argue here, not only from my own experience, but from the experience of the field, I would say, that neuroscience does really need philosophy, and you should not view it as philosophers kind of trying to neuroscientists trying to overtake the realm of philosophy. So in recent decades, not recent years, I would say, neuroscience has started dealing with more and more abstract problems. Later today, you'll hear from Aaron Scherger, my colleague, who's going to talk about consciousness. Ralph, I don't know if you're going to talk about that, but he's an expert in emotions. Okay, I study free will, so we're all neuroscientists. We all study these very murky and very complex concepts. The question of what is free will is an interesting question. Certainly, what is volition? What is consciousness? What is an emotion? Those are very complex concepts. And conceptual clarity in our field is increasingly important, therefore. Okay? It's, otherwise we risk being Libet. We risk saying, oh, I think I know what free will is. I'm going to study it by raising my hand. And then maybe 20 years later and $20 million later in grants that you wasted on it, a philosopher convinces you in 10 minutes that you've spent your career on something that is not the right concept to study. It's funny, but it's maybe not. And I'll say a bit more about that. So conceptual issues become central to neuroscience. And I would argue that neuroscientists are just not well trained to carry out conceptual analyses. That's not something we typically teach. We actually do teach it a bit here at Chapman. I'll get to that, but it's not something that's there in your PhD courses, conceptual analysis in neuroscience, when you do a PhD in neuroscience. So neuroscientists, again, especially those who want to study these high-level concepts, in my opinion, can do one of two things. They can learn more philosophy themselves, or they can collaborate with philosophers. So should neuroscientists learn more philosophy? Of course, yes, it's always good to learn everything that you can, as much as you can. But one thing to note, and I have to say that I felt that for some of my colleagues, philosophy is that thing that you do after you smoke that thing that was recently legalized in California, a bit too much. And, you're kind of sitting there and you're saying, oh, the world is all water or something. And, well, no, right? It's not. Philosophy, again, I know I'm preaching to the choir here, but still, philosophy is a profession. It requires very specific skills and very long training. Again, I don't think I have to tell you this, but I felt I had to say it a few times in conferences in my field. And it's also true that somebody can be an excellent neuroscientist. And I've seen some really, excellent neuroscientists, top of their field, but they're not good philosophers. And they might just not have what it takes to be a good philosopher, and that's fine. So that's one issue. The other issue is, as a neuroscientist, I'm expected to do many things. I have to learn to become a manager, to run my lab. I have to learn to become to learn how to smile right to grant funding agencies to get my grants. I have to learn how to, all those other things. It's a very competitive field. And if I'm now expected to also learn 10 years of philosophy in the mix, it might put me at a detriment to other people. And these fields are not close to each other. So I would argue that instead of neuroscientists, imagining themselves to be these really great philosophers, they might end up with something like this instead. I don't know what that is, but it looks to me like a philosophish. Okay, so I would argue that yes, it might be better for neuroscientists to collaborate with philosophers. But of course, collaboration with such distant fields has its own issues. So what can philosophers do for neuroscientists? One, they can help design experiments. As I said, I think it's getting increasingly important to clarify the research questions and hypotheses before you run the experiment. What are we studying here exactly? What are the concepts that we're studying? And then you get your results. And maybe like Libet, you get a result that suggests that you can predict whether I'm going to go like this or like this for no reason and for no purpose, and then claim immediately in that same paper that this has profound implications for moral responsibility. You're brought before this judge because you raise your right hand and not your left when prompted to raise one of your hands. It sounds ludicrous, but it's there in the paper. So I would argue that philosophers can also help with the interpretation of the results, and with designing follow-up experiments, as we often do in neuroscience. And for those of us that are doing models, again, I think that trying to understand what it is exactly that you're modeling, what are the concepts that you're modeling, what is the outcome of that model is no less something to discuss with philosophers. Now, I think it's not a one-way street. I think that neuroscientists can also help philosophers. And I mean, nothing works if only one side gives to the other. So first of all, neuroscientists generate data, right? There is, I mean, I see our president here. So there's this joke about this guy coming to the president of the university and saying, I need another big I need $5 million for that. And the president says, why can't you be like the mathematician that, just comes here and says, I need a piece of paper, I need a pen, and I need a trash can, or even better, the guy from philosophy that just needs a piece of paper and a pen. Now, I mean,
never said any.
No. That's not that did not happen in real life. It is a joke. But
So this is why
yeah.
Yeah, very good, and we cost enough. Very good.
And you're going to save on trash cans.
Close the neuroscience department.
Yep. But for that, you have to open a neuroscience department first. Anyway, so neuroscientists generate data. You can argue whether it's good data or bad data, but then you can write a lot of papers about whether it's good data or bad data. So we feed philosophers for many years. And it's interesting, James, who was here yesterday, right, from Irvine, was talking about how philosophy moves at a different pace. And it's interesting because very few neuroscientists still discuss Libet that much, but it's still I mean, I have this ping on my Google Scholar whenever there's like a Libet-related paper that comes out. And as you can see, I get a lot of those pings. A lot of those are philosophers still discussing Libet, because in that field, the like time moves differently than it does in neuroscience, and not necessarily in a bad sense. It's those papers are sometimes good. It's not that. But I would say that the Libet and the follow-up experiment have led to a huge debate in philosophy. So there is something that neuroscientists can give to philosophers. And I'll give you another example. This is not that common, I have to be frank, but some philosophical discussions can actually benefit from neuroscientific data. An example, I'll try to make it brief, is called the double effect. So a double effect is this idea, actually with all the wars now in the world, it happens quite often. Let's say that the army knows that there's an enemy base that's situated very close to a school. Now, according to international law, the laws of war, it is okay to target that enemy base. It's a legitimate military target, while knowing that you would hit the school. It is not okay to do the exact same thing, targeting the same military target, while intending to hit the school. So foreseeing versus intending makes all the difference in these examples between something that is legal and something that is illegal according to international law. So your mental state, which is arguably your brain state, really matters in such situations. So there are, and I mean, there is an ongoing philosophical or philosophical legal debate about whether in these situations you can foresee something that, because I mean, the idea here is that you're this military general and you know that if you hit the school, let's say it will help you militarily for a moment for our discussion. And the idea is, well, can you then, you know it's going to help you, but you still don't intend to do it, you just foresee. And there's been ongoing philosophical debates about that. And so we actually are running an experiment now, of course, not with any of these horrific situations, but something that our IRB approved. And that's the ethics board, if those of you who don't come from these sciences, the ethics board of Chapman approved, which lets us really see what happens. And maybe we can inform those legal philosophical debates from about what happens in the brain. Can you foresee something without intending it, if it benefits you, and so on. So, you know, I'm saying that these collaborations are good. Now, I will also say that, you know, they exist, they happen. So I actually led two of those. One was called or still is, it's an ongoing, called the Neurophilosophy of Free Will Consortium. And it has scientists and philosophers from all over the world that are collaborating on questions related to, does consciousness have a causal role in the initiation of action? Those questions that still resonate from the Libet experiment. We also before talked about a lot about whether one thing causes another. And the question of causality is quite complex, right? It's kind of easy to think about it with billiard balls, but what happens when you have a neural network that's very complex and you know, things are feeding back. So there's another consortium that we have where we call it the Causality and Spontaneous Action Group. Again, you've got your philosophers and you've got your neuroscientists, and we work together and we listen respectfully to each other and we learn from each other. So just to say, this is very much possible. But I would say that, to be clear, there are challenges in this collaboration. And in this sense, my talk is more practical, I think, than theoretical. So one issue is distrust. Some neuroscientists, you know, I've spoken to them, they tell you philosophers have had their chance. They had 2,000 years to solve the problem of free will. If they couldn't do it in 2,000 years, now it's our turn to try. You know, what do we have to learn? They don't go anywhere with their debates. It just stays, it's like an ongoing vicious circle. It's not, in my opinion, but some people say that. And then you've got some philosophers who tell you, and I've heard this, they said to me, I have nothing to say to you because neuroscience cannot contribute to the free will debate on first principles. I'm not sure what that means, but apparently it's bad. So basically, there's nothing I can say that would be of any meaning to their debates. So there's the issue of distrust. Sorry, Marco, you had a question? I don't know. That's what they keep on saying. That's why it's in quotes. I keep on hearing this, that on first principle, basically there's nothing you can say that matters to the debate. Again, I'm putting this here because I've heard it, but I course, don't agree with it. And there are many other philosophers who happily collaborate with neuroscientists. But in terms of barriers to the collaboration, there is also the issue of knowing a little bit about something is sometimes worse than knowing nothing at all, right? It's like this guy who went on the internet and looked up their disease, and they now know what to tell their doctor, what's going on. Don't you try to fool me. I know everything because I Googled it last night. So yeah, some neuroscientists really think they're good philosophers, perhaps even better than the professional philosophers. And I have to say that I've met philosophers that understand neuroscience in a superficial manner, yet then make various claims about it. There's also, you sit with a philosopher and you design an experiment. And it takes half a year and you design it really carefully. And now you tell them, okay, now I'll run the experiment in the lab. Then 2 years later, you come back to them with a result. But a few months after you talk to them, they said, hey, we met all those times. What happened since then? And you say, I'm still waiting for the approval of the ethics board. I'm still trying to recruit the research assistant. We got the data, but there was a technical problem. We have to so these are fields that move at different paces in both directions. And I've had philosophers quite frustrated saying, yay, but we talked about it. What's taking so long? You want the analysis to be really good. It takes a really long time. So there's that. There's also the fact that some of the disciplines just don't know that much about one another, right? So we had these meetings, the neurophilosophy of free will, and I actually had philosophers come and say, actually you guys really do some kind of philosophy to some extent, right? You deal with like philosophical questions. And then you get neuroscientists coming back and saying, oh, you know what, actually those discussions with philosophers, that was enlightening, that was good, that was useful. But it really takes a long time to talk to each other. Sometimes different disciplines mean different things by the same term. I'm trying to remember, there was one thing that really, well, it's not, maybe it'll come back to me, but there was like a philosopher who came to me after a talk that I gave and asked me about something that I thought was such a trivial term that I didn't even think that it's worth defining. But, it's not, they didn't understand what it was. And of course it was on me, but I didn't realize that it was an issue. There are also very, very practical barriers. There are different career incentives in the two disciplines. So books are really big in philosophy. Many philosophers make their name with that book, right, that people read. Very few neuroscientists make their names by a book. It's usually a paper, right, or a series of papers. And then they write the book afterwards. Grants are really critical for neuroscientists. Most philosophers don't need them. Some do. Some actually have labs, but most don't. There's also like small things like neuroscientists really like to work in groups, and many, many philosophers publish on their own. Again, it's a little, I think it's changing a little bit, but still, you don't have this paper that I showed you before. Let me bring it up again. This one here. So this is a neuroscientist, philosopher. So somebody told me that this was the greatest number of philosophers who published together that they've ever seen, or something like that. Okay. So thank you. So that's worth noting as well. So yeah, there are structures there that are worth noting. Now, it's also really important to understand when you have these collaborations going, what to expect from each other, in my opinion. So neuroscientists can make good, real progress on the neural mechanism of the question that you're studying together. In this case, maybe desires and beliefs, how they lead to actions and intentions and so on. But don't ask me whether determinism is true or not. There are people here who do maybe quantum mechanics, and maybe they can say something about that, but I don't know. I talk about neural mechanisms. There's what to expect from each other, right? And in the same way that, philosophers can help you clarify concepts, they can help you talk about, your research hypotheses. Don't expect them to know how to do statistical analysis better than you, or to come up with some kind of a really great control condition. Again, different fields have different training. Now, I said this before, but I'll say it again because I think it's worth saying. Interdisciplinary does not mean that every neuroscientist has to become a philosopher. And I say this every time I give these talks. I am not a philosopher. I don't think I'm an especially good philosopher. I know how to talk to philosophers because I've tried to do it for a long time, and I think I learned how to do it. Neuroscientists does not have to become a philosopher. What has to happen is that they need to be willing to put in the time and the effort and the respect to talk to the other side and really learn to understand what the other side has to offer. And I would also say that it's important to stay humble. The fact that you had lunch with a philosopher does not make you more of a philosopher than eating fish makes you have gills, okay? So in terms of creating a truly interdisciplinary collaboration, it takes time. You have to understand what each person brings to that collaboration. You have to find a question that's interesting enough for both sides to put and invest that time in. Otherwise, people are going to walk off. It's just not of enough interest. Sometimes it won't work. Now, the fact that if it doesn't work, it doesn't mean that philosophy and neuroscience shouldn't collaborate. Maybe you should not be collaborating with that philosopher, or that philosopher shouldn't be collaborating with you. Just, you'd have to try again. And if you can create some kind of an incentive structure, for instance, in that neurophilosophy of free will, we baked into the grant that every project has to have at least one philosopher and one neuroscientist. And that helped when the papers were published, right? You saw the difference. Another thing that we do I believe it's unique to Chapman, at least I don't know of anything else anywhere else in the world that does this, is there's a joint course that I teach with a philosopher, Michael Robinson, from the philosophy department here. I haven't seen it. I don't think Michael is here, but he's with us in spirit because he and I discuss this a lot. And we do this for undergrads. So we take undergrads and we deliberately take roughly half from the sciences and half from the humanities, and we put them in the class together. And with the idea that if we start early with the training, it would help later on. And we study the Libet experiment. They read the original paper or one of the original papers, and then we read various papers by philosophers. And of course, each side has more difficulty with the papers from the other side. But we're there to help, and we do this. And then in the end, their task is, because we cover some of them, not all, but much of these basic literature in the field, and their task is to design an experiment together. Again, in every group, there has to be at least one philosopher and at least one neuroscientist. And they have to design an experiment together that would go beyond what has been done. It's just a design. They don't have to carry it out. But some of their ideas are great. Every year I think to myself, okay, the next PhD student that I get, I will suggest that as a project. So that's something that we can do. And I would just, if you're interested in this, Michael and I made this video that we put on YouTube calling Why Neuroscience and Philosophy Need Each Other. And it's been animated by the same really talented people from the Chapman Film School that you saw all these nice characters here. So if you want to see more of those characters, go look at that video. And I will end here. Thank you very much.